Small thing but important. Have a look. This is accelerating downwards. 2 minus 1 by 2 plus 1 into g. Yes or no? After traveling a distance of 1 meter, there is a floor. 2 kg mass sticks to it. 2 kg mass sticks to it. 2 kg mass sticks to it. Right? When 2 kg mass sticks to it, what happens? The tension in the string will become 0. Now this travelled up by 1 meter, this travelled by 1 meter. Right? Now here the 1 kg mass has some velocity. And the tension in the string became 0. If the tension in the string became 0, after how long do you think the string will again become taut? Now this stopped here. This stopped here. This acquired some velocity. Tension became 0. Now this will fly up and come back. Yes or no? If you can tell me this velocity, if you tell me this velocity particular velocity, how will you tell you that velocity? V square is equal to u square minus 2gh. Right? It is going down. What is the velocity of the 2 kg block just before striking? V square is equal to u square plus 2a 1 meter. Initial velocity is 0. This will be g by 3. G by 3 into 1. 2g by 3 with a square root is the velocity of this block just before striking. Same will be the velocity of this block. Right? This velocity is root over of 2g by 3. Now this sits on the platform. Tension in the string became 0. Now what is the acceleration of this g in the? Now this will fly up and it will come back. How much? What is the total time? 2u by g. When I project something with a velocity u, it will go up and come back. Velocity will be 2u by g. 2 by g into velocity is root over of 2g by 3. This is the time after which the string will become taut again. Is the logic clear? Taut matlab tight. On the contrary, look at what they did. This is 1 kg block, 2 kg block. After it travelled a distance of 1 meter, 2 kg block stopped for a fraction of a moment. 2 kg block stopped for a fraction of a moment. Right? And released. Here what is the difference between this and that? Here you blocked it permanently. Here आपने रोक के छोड़ दिया. When you stopped for a fraction of a moment and released, what happens? You made the velocity 0. When this came down by 1 meter, this will also go up by 1 meter. Right? This velocity will be how much? Root over of 2g by 3, same 1 meter. So root over of 2g by 3. Here what did you do to the 2 kg block? You didn't stop it permanently. You stopped it for a fraction of a moment and you released it. Right? If you stopped it for a fraction of a moment, velocity became? Iska velocity will be root over of 2g by 3. But when you stopped it for a fraction of a moment, tension in the string became 0. आपने 1 मिनट के लिए रोक दिया, So this continued to move upwards. So tension became 0. Now what is the acceleration of both? G in the downward direction. When will the string again become taut? Distance moved by this and distance moved by this should be the same. Distance moved by this and distance moved by this should be the same. This is half gt square. This will be vt minus half gt square. V is this velocity, or call this u so that you are comfortable with the formula. This distance, when it is equal to this distance in the same time, that means ut minus half gt square is half gt square. Ut is equal to gt square. T is equal to u by g. Can you recognize that this is the time taken by the particle to go to the maximum height? When this goes to the maximum height of its projection, the string will again become. Is the difference in two situations clear?
Yes.
A very subtle point where if the examiner actually wants to create a tough problem, he will give you this question. Not there in your booklet. These are slightly tricky things which I will discuss right now.
So it becomes loose.
It becomes loose. The moment you stop this, the string is not taut. Now it is falling with an acceleration of g. This is thrown up with this velocity, so it is decelerating. When this distance is equal to this distance, the string will again become taut. Right?
So full friction this one.
When the string is taut, this is the acceleration of this block. To calculate this velocity.
The acceleration. Yes, sir.
This is K1. Block A, block C is of mass M. Block B, block A, this is 2M, this is 2M, this is K2. A and B. You cut the string. At that instant, find the acceleration of A, B and C. At that instance, find the acceleration of A, B and C.
That is A0.
A is 0 is correct. Hence among the four options, चारों ऑप्शंस में एक्सेलरेशन ऑफ ए 0 ही देंगे, वरना अगर एक ही ऑप्शन में एक्सेलरेशन ऑफ ए 0 दिया है तो बाकी दोनों आप कैलकुलेट ही नहीं करेंगे। तो पेपर सेटर को भी थोड़ा बहुत दिमाग आप लोगों ने सिखा दिया। आपके पास रिमोट कैसा है भाई?
सर वो इसके पहले वाले क्लास में मैंने दे दिया था।
लो वापस दो। ऑफिस में देखा रहो। Okay, I'll call you. Please put down the phone and in class I'll call you. Right? Now, K1x1 2mg, K1x1 plus 2mg should be equal to 2mg.
खाली mg
Just a minute. mg, sir. This is mg. So how much will K1x1 be equal to? mg. K1x1 is equal to mg. This is in equilibrium.
Yes.
You understood how we found out K1x1?
Yes.
It was a smart move from the reverse calculation.
Yes.
Now that this string is cut, 4mg will become 0. 4mg becomes 0, this 2mg will become 0.
Yes.
K2x2 will not change, acceleration of this will be 0.
Yes.
Now acceleration of this is 4mg upon acceleration of b is 2m. This will be 2g. Acceleration of this will be 2 mg upon m. This will also be 2g downwards. इसका acceleration will be 0. Richness is a property of mind. It has got nothing to do with your purse. When I was earning 1800 rupees fellowship when doing research, I was much richer than now. Reason? Then I was very happy with what I was getting and my expenditure was minimal. So 1800 rupees I used to feel very rich. The day UGC Grants Commission increased that to 2500, we were इतना खुश थे कि we didn't know what to do with that money.
We went to 3-star hotel and
We spent 700 rupees. 3 घंटे बैठ के भर के खाए.
डोसा
दर्शिश का
This is 30 degree. This is 30 degree. This is moving to the left with the velocity of u. This is moving with the left to the right with the velocity 2u. Now I am interested to know the velocity of the cylinder kept here in contact with these two. This is 30. Right? This is also 30. Velocity of this cylinder. This is the cross-sectional view. Find the velocity of cylinder. Find the velocity. It matters not. This is some wedge. This angle is 30 is important. This is the cross-sectional view. Cylinder बोर्ड के circle क्यों draw किया यार आपने? It is this circle. It is this circle. Cross-sectional view. It's a cylinder kept in between. क्या? कुछ नहीं.
इसको रिजॉल्व सर्किल बनाना
तेरे लिए.
यस सर कंडीशन क्या बोला
ए मूवी बना
कंडीशन आपने क्या बोला
Hey, wedge constraints का statement देखो आप लोग भूल गए. कैसा लोगे संडे का टेस्ट? At the point of contact, velocity of both the bodies along the common normal will be the same. At the point of contact, velocity of both the bodies along the common normal will be the same.
अटैच्ड है सर
हाँ? Attached नहीं, attached है तो why will it move? Along the common normal will be the same. At the point of contact, along the common normal, at the point of contact, velocity of both the bodies along the common normal will be the same.
क्वेश्चन नहीं समझा
Find the velocity of the cylinder.
नहीं वो नहीं मतलब हाँ वो डायग्राम ऐसे
The right wedge is moving to the right with the velocity of u. Left wedge is moving to the left with the velocity of u. At that instant, velocity of the cylinder चाहिए. हाँ?
मतलब ये नीचे गिर रहा है ऐसे
नीचे भी गिरेगा, to the right भी जाएगा. Now listen. Have a look. This will have Vx, this will have Vy. Cylinder का velocity किस direction में रहेगा I don't know. So this will have Vx and this will have Vy direction. Right? Now Vx will be equal to 2u at the point of contact along the common normal. Vx is equal to 2u. Right? Now along the common normal, along the common normal, this u, have a look at it. This u will resolve in this direction. This will be 30. This will be u sine 30. Now here, this will be 30, 90, this will be 60. Vx cos 60, this will be Vy cos 30. Now, iska velocity at the point of contact along the common normal, Vy cos 30 minus Vx cos 60, Vy cos 30 minus Vx cos 60 should be equal to u sin 30. Vx is equal to 2u. Vy is what I will have to calculate. Vy root 3 by 2 minus 2u into 1 by 2 is u by 2. Vy root 3 by 2 is 3u by 2. 2 will go. Vy is equal to root 3u. U root 3. This is Vy. This is Vx. So velocity of the cylinder is 2u I cap minus u root 3 j cap. Velocity at the point of contact along the common normal of both the bodies should be the same. Along the common normal, yaad karo, if you have taken one block like this, theta, this is moving with V0. You said this is Vy. If this is theta, 90 minus theta, Vy is V0, cos 90 minus theta is V0, sin theta. Agreed?
Yes, sir.
तेरी तारीफ हो रही है कितने प्रॉब्लम था
Now listen. Hello.
तुझे तो नहीं था
2.5 kg. This block is in equilibrium. Find the reading of the spring balance. Write on the statement. Find the reading of the spring balance when capital M is in equilibrium. Find the reading of the spring balance when capital M is in equilibrium. Find V by 2, 3V by 2, V1 is 3V by 4. I am surprised, amused and shocked that neither are you applying constraints properly nor principle of virtual work. T cos 60 and T sin 60 क्यों नहीं लिया भाई साहब आपने? उस डायरेक्शन में वेलोसिटी है ही नहीं. Right? Yes or no?
सर T cos 60 लेने के बाद
You are pulling with a force of F. This is M, point P. Free end of the string is pulled with a constant force F. Find the acceleration of point P. Find acceleration of point P. Find acceleration of point P. Slightly tricky question, hence I am discussing it in the class.
So it not be an exact value.
Range रहेगा.
No sir, I'm telling you it won't be like 1, 2, 3, 4, it will take.
Answer पूछ रहे हो.
No sir, it will be in terms of M or not.
In terms of
M or M.
F and M. It will be in terms of F and M. This will be F. Suppose I take this to be acceleration of A1. This block to have an acceleration of, this will be 2F. That means this will be A2 in this direction. Am I right? So 3F is equal to 2M into A1. 2F is equal to M into A2. 2F is M into A2. Agreed? Now, have a look. I need the relation between the constraints. Have a look at the constraints carefully. This point has an acceleration of P to the right. Right? Segment 1, segment 2, segment 3. Say something. This point and this point has an acceleration of A1 to the right. This point also has an acceleration of A1 to the right. These 2 points have an acceleration of A2 to the left. Right? Segment 1. This point is moving away from the center. Acceleration of the point P. This is minus A1. This is minus A1. This is minus A2. This is minus A2. Minus A1 should be 0. Plus AP. Minus A1. Minus A1. Minus A2. Minus A2. Plus A1. Acceleration of the point P. 2A1 plus 2A2. 3A1 plus 2A2. Right? And he is asking you for acceleration of P. Calculate A1 and A2 and substitute here. 3 times A1 is 3F by 2M. 2 times A2 is 2F by M. This will be 9F by 2M. 4F by M. 2M, 9F plus 8F. 9 plus 8, 17F by 2M is the acceleration of point P. कौन सा? कौन सा? ये इक्वेशन में नंबर बोलो लास्ट में. This is moving towards the center of this segment. Negative. Anything moving towards the center of the segment? Negative. Moving away from the center of the segment? Positive. ड्रॉ करो. ये दोनों हवा में थोड़ी है. वो तो masses around the ground. रिकॉर्डिंग किसके लिए?